Hello, my name is Hamid Ojatian. I'm a PhD student at Polytechnic Montreal. My research topic is applied machine learning in wireless communication, especially massive MIMO and hybrid beamforming. Today, I want to present the last update of my research topic, which is the unsupervised deep learning for massive MIMO hybrid beamforming. First, I will explain a little background and introduction. Then I explain our method for the single base station hybrid beamforming, followed by cell-free cooperative hybrid beamforming, and finally, conclusion. 5G generation of wireless communication deploying all around the world, and by increasing the number of connected users to the wireless network, 6G mean to deliver up to 50 times throughput compared to 5G of wireless communication. However, it costs more energy consumption and increase the cost. And for the first time in the 6G, we can see that energy efficiency is one of the main KPI in the 6G. So high data rate, high user density, and low power consumption required breakthrough technologies, and massive MIMO, massive multiple input, multiple output technology introduced last decade, previous decade, and it allows very high throughput and serving a large amount of users at the same time. However, there's two main issues with the massive MIMO. First one is hardware complexity, because each antenna in the base station required one RF chain. And the other issue is CSI acquisition. CSI is channel state information, especially in the FDD communication, frequency division duplexing. CSI is the information between the users and the base station required to transmit the data. To address the first challenge, hardware cost, hybrid beamforming proposed, where the combination of digital precoder and analog precoder used to reduce the number of RF chain, and in the analog precoder use phase shifter, low-cost phase shifter, and almost address the first issue. However, the hybrid beamforming design, because there is the coupling of digital precoder and analog precoder, there is more complicated problem to solve to design the digital and analog precoder. So to address these CSI acquisition and complicated detection technique in the hybrid beamforming, we propose RSSI based. RSSI means receive signal state indicator, hybrid beamforming powered by deep neural network. The first RSSI based is instead of CSI, channel state information. It's required less signaling overhead, and deep learning reduce the complexity. In the single base station hybrid beamforming scenario, we propose unsupervised learning, where in the training phase, the deep neural network fed with the Quantas RSSI instead of CSI, and the loss, we assume that the CSI is fully known in the training phase, and the loss function is designed based with a negative sum rate. When the deep neural network try to minimize the negative sum rate, actually we are unsupervisedly maximize the sum rate. And in the online mode, RSSI is the only information base station has and can design the hybrid beamforming vectors. So using unsupervised learning, there is no need to compute the optimal hybrid beamforming solution as a target. And no computation required to pre-processing the data set, and it will reduce a huge amount of cost and complexity in the training phase. And this network, we proposed two alternative solution for the deep neural network, and since the analog precoder is the phase shifter, quantized phase shifter is going to be a classification, and the digital precoder is a regression task. So it's going to be multitasking deep neural network, and this loss function is designed for the multitasking deep neural network. In the HBFnet, we call it HBFnet, the first architecture, the digital precoder and analog precoder provided at the same time jointly. However, due to misalignment between the analog precoder and digital precoder is going to affect the sum rate performance. And the alternative solution, AFPNet, with the deep neural network provide the full digital precoder and analog precoder, and by using the pseudo inverse, we can compute the digital precoder. Due to alignment between the digital precoder and analog precoder, it has better sum rate performance. However, due to some post-processing computation, it is high complex than HBFnet. We evaluate our performance with the deep MIMO millimeter wave massive MIMO dataset. It is the ray tracing channel model. We evaluate our proposed method with three different scenarios where the user located randomly in limited area, and the base station 7 or 8 soon to be serve the users a limited area, extended area, and crossroad area. And we compared the sum rate performance and we compared with the conventional non-deep learning method, phase zero forcing, orthogonal machine pursuit, and HSHO as the optimal solution. We consider 4 users, 64 antennas, and 8 RF chain. And we can see that our 2 proposed methods outperform other solution. And it is for extended area, crossroad area again, and limited area in 3 different scenarios. In terms of computation complexity, we compared the number of real value multiplication to compare the computational complexity, and we can see that our 2 alternative proposed solution required less number of multiplication in compared to conventional method. And all of these results published in the journal IEEE Transaction and Wireless Communication 2021. As an extension to this solution, we extend to cell-free cooperative hybrid beamforming, where multiple APs, access point, or base station equipped with analog precoder and digital precoder hybrid beamforming serve the user at the same time. All of these APs connected to the network controller, and in the conventional method, there is a huge signaling overhead between the APs and network controller because the beamforming vectors should be designed jointly. For example, these 2 beams need to be designed jointly, so there should be a centralized unit to design the precoder for each base station individually. So this signaling overhead can be reduced or even eliminated. That's why we propose 2 approach: fully decentralized architecture and partial decentralized architecture. In the fully decentralized architecture, in the online phase, each base station can design the hybrid beamforming vectors respect to other base station. And in the training phase, they are training together, jointly together in the network controller. The main idea behind this solution is to globally train the deep neural networks or base station and execute them locally in the base station. In the partial decentralized, the network controller is still engaged in the online phase. However, the signaling exchange between the network controller and AP reduced by using autoencoder techniques in the last shared layer and first of unshared layer of each APs. These 2 technique is not limited to hybrid beamforming and can be used, can be deployed for the full digital precoder. Again, we evaluate our performance with the deep MIMO channel model extended area, and we consider 2 base station and 4 base station, 64 antennas and 8 RF chain. We compare with the zero forcing as a fully digital precoder technique, and it is centralized. So it is centralized and fully digital precoder, you should have the best performance. And we again compare with the full digital precoder conjugate beamforming. Conjugate beamforming is a decentralized approach. Of course, since it is a decentralized, going to have less performance compared to zero forcing, and you can see that our two approach, decentralized approach, although they're decentralized, they get the near optimal solution, near to even zero forcing. And in terms of hybrid beamforming, near optimal solution is shown here, and two other hybrid beamforming solution can be seen as close to near optimal solution. In terms of number of complexity and signaling overhead, we can see that our two proposed approach in both number of multiplication and signaling overhead outperform other solution, and these results submitted to the possible publication in IEEE journal. As a conclusion, we can see that we avoid the full CSI to increase the spectral efficiency. We propose RSSI-based hybrid beamforming. We propose unsupervised learning approach to decrease training time and cost by training. A novel extension to cell-free communication proposed to limit the signaling exchange between the network controller and APs. And the base station can be trained unsupervised to robustly design the hybrid beamforming while achieving a similar sum rate as a near-optimal hybrid precoder. Thank you, and sorry, one more minute. Thank you.